Hello students, good evening. Let's try to understand what exactly happens in a voltaic cell or a galvanic cell versus the electrolytic cell. Now, what is this electrolytic cell exactly? I'll help you understand today. First of all, let me clear you one small thing. Anode and cathode can be really a confusion. Which of them gets a positive charge? Which of them has a negative charge? That can be a huge confusion. Let me help you out over here. First of all, when it comes to CBSE NCRT new syllabus curiosity book, whoever is following, the concept of anode and cathode is not there in your voltaic cell. They only consider electrode 1 and electrode 2. So one thing is sorted, that you do not have to worry about anode and cathode at all. But others who are also studying more about it, let's understand this a little more in detail. First of all, let's get the difference. Voltaic cell is where a chemical reaction occurs, and that chemical reaction results in electricity. Simple. But electrolytic cell is where electricity is provided, electricity is given for a chemical reaction to occur. This is electrolytic cell. Now, how cathode and anode happens? See, one in a voltaic cell, what happens is the anode side. This is a more reactive element. It reacts with our electrolyte and it gives out electrons. So when it comes to voltaic cell, since the anode is giving away electrons, a lot of electrons are accumulated at the anode end. So anode will be negative, whereas cathode will be positive. So the reaction that occurs at the anode side is an oxidation reaction. So oxidation occurs and that oxidation causes the electrons to be released, negative ions to be released, because of which anode is negative. But when we come to a electrolytic cell, let's talk about the electrolytic cell. Here, what happens? An external battery is provided, as you can see. So this battery pushes electrons to the cathode. Since it is pushing electrons to the cathode is your negative side. Cathode gets the negative end. Anode, the electrons are being pulled from here. Since the electrons are being pulled, anode gets a positive charge. But remember one important thing, in both the sides, it is oxidation only that is happening on the anode end and reduction is happening at the cathode end. Both the ends, no matter which cell it is we are talking about, same thing happens. Now, why are we providing electricity in an electrolytic cell? So, students, when we want an, uh, you know, copper, for example, or if you want any other metal to be deposited on a surface, in that case, we will use an electrolytic cell where we are providing the electric current and a chemical reaction occur and electroplating happens. But when we want an electricity to be generated, like if you want to light a bulb, in that case, a voltaic cell is used. Electrolytic cell is just an advanced version of a voltaic cell. The basic funda is simple. Chemical reaction is occurring and there are ions, oxidation and reduction chemical reaction occurs, because of which ions are released. And these ions, if you're talking about a voltaic cell, we talk about the accumulation of charges, which gives a positive or a negative charge to our electrodes. When it comes to an electrolytic cell, we talk about what overall charge the electrodes have because of electrons being pulled and pushed to one or the other end. Coming to the ones who are following the NCRT syllabus purely, the new textbook, you do not have to worry about anode being positive, negative, cathode being positive, negative, or what exactly happens. You can write the simple terms. A chemical reaction occurs, which generates ions to be released into the electrolyte, which move from one electrode to another, causing an electric current, which can light an electric lamp. A chemical reaction resulting in electricity. A chemical reaction resulting in electricity. This is what matters when we talk about a voltaic cell. Thank you so much, students. I hope the concept is now a little clear.